Hey Chem Kids, Mr. C here, and today we're going to do an experiment based on intermolecular forces. And specifically, we're going to be looking at evaporation and how evaporation links and kind of tell us a little bit about the relative strength of intermolecular forces. So basically what happens when something evaporates, it's an endothermic process. And all that means is that it cools things down because it kind of sucks in all of this extra energy and it doesn't release any energy. So it cools things down. And the magnitude by which something cools down, so like the bigger change in the way something cools, tells us something about how strong the intermolecular forces is. Similar to like if you have a high boiling point, we know that you have a strong bond. Well, if we have a large change in temperature, we can either know that we maybe have a strong bond or maybe we have a weak bond. And the purpose of this lab is to determine what a high change in temperature means for bond strength. So we're going to look at a couple different chemicals. So the first one we're going to look at is we're going to compare hexane and heptane. And then the next one we're going to do methanol and ethanol. Then we'll do acetone and isopropanol. And then finally, we'll look at water by itself at the end to sort of determine what the temperature change is. And the way that this is going to work is for each of them, I have little samples of each of them. So like in this case, I have heptane and hexane, and I'm going to squirt them on my temperature probes, which you can't quite see here, but I have them linked up to the logger pro over here. And I'll show you my whole setup at the end of this video. But basically, I'm going to squirt one of each of these onto each of the temperature probe. And I'll tell you which one I'm going to use for which. And then after I do that, I'm going to record for 240 seconds and see which one has the largest change in temperature. So we're going to look at like what their starting temperature was or what their maximum temperature is. And that's what we're going to record for T1. And then we're going to see what the minimum temperature is. And that's what we will record for T2. The other columns in your table, you'll have to fill out on your own. I won't be going over that in this video. So the molar mass, you'll just find the molar mass of each of those substances. We provided you the chemical formula for everything except for water. Water is just H2O, in case you forgot that. And then you'll have to ask yourself, is there a hydrogen bond or is there not a hydrogen bond? And remember, to have a hydrogen bond, you have to have an H bonded to an O, an H bonded to an N, or an H bonded to an F. So I'm going to go finish getting things all set up and ready, and then we will start our first trial. Okay, so we are ready for our first trial. So we are going to do hexane and heptane. As you can see, I've sort of changed the colors of my temperature. So I have temperature 1, which is going to be yellow, and temperature 1, or the yellow one, is going to represent hexane. On the graph, it'll be the red line. So hexane is going to go with temperature 1, and then heptane over here is going to go with temperature 2. So I'm going to go ahead and start the recording. I'm going to let it run for a few seconds. Then I'm going to put my hexane on the yellow one, and I'm going to put my heptane on the black one. So I'm just really soaking them in. And they're good. And now I'm going to let the data record for about the remainder of the time. So we still got a good, decent chunk in time. So we're going to watch the temperature change of these two probes. Notice how already we can see our temperature 1, which represents hexane, is seeming to decrease in temperature much faster than temperature 2, which is heptane. I'm going to go ahead and pause the video now and wait for the experiment to run, and then I will bring you back and I'll show you the complete final data for this run. Welcome back. We are almost to the end of our first trial. We only got a few more seconds left, and then I'll run some statistics and we'll be able to record what our maximum temperature is. And remember, that's going to be T1, and we can record our minimum temperature, which we will record as T2. So we got about probably 20-ish more seconds left. Notice here how our blue temperature still continued to decrease fairly slowly, whereas the red temperature decreased very, very fastly there. So it evaporated very quickly. And now we can actually see that the red temperature has actually started to increase already. Okay, so all of our data is done. Now I'm going to go over here and I'm going to highlight the whole graph. And I'm going to calculate some statistics for us so that we can see what our maximum and what our minimum is. We'll do it for both of our temperatures, and we got it here. So for temperature 1, if you can see this hopefully in the video, temperature 1, which represents our hexane, had a minimum temperature of 9.296, which you can just record that as 2.3 or 9.30. So that's going to be temperature 2, because temperature 2 is our minimum temperature. And then we see that our maximum temperature was 21.17. If we look at temperature probe 2, that represents the heptane. Our minimum temperature, which we'll record as T2, is going to be 12.19. And then our maximum temperature is going to be 20.58, which is what we record under T1. So I'm going to go pause this video now. You can go ahead and calculate that temperature difference and make sure you can figure out what the molar mass of each of these molecules are and whether or not they have hydrogen bonding. And then we will start our second trial. Welcome back, Chem Kids. We are now going to our next trial. So we're moving down. We're now going to look at methanol versus ethanol here. We're going to put methanol on the yellow probe. So methanol is going to be on temperature probe 1, and ethanol is going to be on temperature probe 2. So I got my probes all set up and ready again. I'm going to hit collect and erase and continue. And we're going to let it run for a bit just to sort of get calibrated. And then, like I said, I'm going to put ethanol on probe 2, and methanol goes on probe 1. So I'm going to really soak them in good. And they're ready. And we're going to let this go, and we're going to measure those temperatures again. So once again, we are going to let this run for 240 seconds. So we still got quite a bit to go. So I'm going to let it run probably until it gets to about 50 for you guys. And then I'm going to pause this video so that you don't just have to sit there and watch it run, because it can be kind of boring. Notice how temperature probe 1, which is that methanol, is decreasing faster at the moment than ethanol is, which is kind of interesting to see. But I'm going to go ahead and pause this video, and I'll be back whenever we're right around that 200-second mark again. Welcome back, even though it's only been a mere second for you. It's been a long 2 minutes-ish for me, but we have reached just past that 200 mark. In just a few seconds, we'll be able to record our data, and I actually think I have it set up so that it will automatically calculate out what our maximum minimum values are, which would be super duper cool. We're going out, we're almost done. Perfect. So we're going to look here and we see our temperature. We see that in the end, temperature probe 1 did end up lower again than temperature probe 2, but that's not always going to be the case necessarily. That's just how it worked out in this lab. So don't think that that's like a pattern between 1 and 2 right now, because that's not necessarily the case. But we look for temperature probe 1, which we had as methanol. Remember, temperature probe 1 is methanol. And we see that its minimum temperature is 8.095, and we can just report that as 8.10 if you want, or you can report out the whole thing. It's up to you. But 8.10, and that's going to go under T2 because our minimum temperature is T2. And we look here and we see our maximum temperature is 22.52. And that's going to go under T1. Then we look over at temperature probe 2, which represents ethanol. And for temperature probe 2, our minimum temperature was 12.11. And our maximum temperature is going to be 21.19. So those are our two temperatures. So now you can go ahead and you can calculate the difference in those two temperatures and record that in the delta T box. Also make sure that you have calculate out what the molar mass for each of those two substances is and determine whether or not there is hydrogen bonding going on there. I'm going to get the next experiment set up, so keep working on this problem, and then we will start our third trial here. I'm back, and we're going to start our trial 3. So for our third trial, we're going to look at acetone versus this 2-propanol or isopropanol. We're going to put the acetone on the yellow one, and we're going to put the propanol on the black one. Or this is going to be, acetone will be temperature probe 1, and propanol is going to be that temperature probe 2. So I'm going to go ahead and hit collect again, and we're going to erase and continue, and we're going to let it run for about 10 to 15 seconds just to to let it sort of get a good baseline for each of our original temperatures. Okay, now what I'm going to do is I'm going to put that acetone on temperature probe 1, and I'm going to put the propanol on temperature probe 2. Okay, so they are soaked and ready. And we're going to let that run for, again, another 240 seconds. Look at this one. Holy cow, that red probe is really going down quite quickly, if I don't say so myself. We're going to let that run for 240 seconds. I'll bring you guys back whenever we get closer to that 240 seconds, so you don't have to sit here and watch it for 240 seconds, because, I mean, it's boring for me, and I'm actually doing it. I can't imagine what it would be like for you, especially because you can't see it, although I guess I can kind of pick it up. I got my whole temperature probe set up here with a bucket of water underneath it to catch it all. Pretty high-tech stuff. Pretty crazy, but that's how it's going. So I'll bring you back in a couple minutes. It will be a couple minutes for me. For you, it'll be like seconds. Okay, I'm back. We're almost done. We're right around 220 seconds right now, so we got about 20 seconds left. Notice how much faster the red one went down. It's kind of crazy. I mean, blue is still decreasing in its temperature, but it did not decrease nearly as fast. And actually, red, we got to negative temperatures here a little bit. I mean, not very negative, so we're just barely below freezing in this case, but still, that's pretty crazy. I'm not looking forward to taking that one off. It's going to be pretty cold. But okay, so we've just finished it now. We can record our temperatures. So for temperature probe 1, remember, that's whenever we put acetone on it. For temperature probe 1, our minimum temperature was negative 0.78 degrees. Holy cow, that's pretty cold. So we're going to put negative 0.78 degrees. And we see that our maximum temperature, we started off at 22.36 degrees. So that was a pretty big temperature drop right there. And remember, that minimum temperature we're recording under T2, and the maximum temperature we are recording under T1. For temperature probe 2, which is our 2-propanol, or that isopropanol, we're going to go ahead and record, and we see that our minimum temperature was 13.75 degrees, and our maximum temperature was 23.01 degrees. So go ahead and record those numbers. While I'm setting up our final experiment, our final trial for this, I know it's sad, this video is almost about to come to an end. Go ahead and calculate the temperature difference between those two, and make sure that you have already calculated those molar masses and determine whether or not they have hydrogen bonding. Remember, be careful with this one. In order to have hydrogen bonding, it needs to have an H2 and O bond, an H2 N bond, or an H2 and F bond. Remember, if it's an oxygen bonded to a molecule that's not hydrogen, it's not going to have hydrogen bonding in it. So keep that in mind when you're looking at these two, because they can be a little trickier in this case. So I'm going to go ahead and pause the video for me. I'll be back in half a second for you while I set up our final experiment. Welcome back. I know it's been half a second for you, but it's been a horribly long time for me. But we are going to do our last trial here. And for our last trial, we are only looking at water, or that wonderful molecule that I love to call H2O. So to do that, I've actually disconnected one of our temperature probes, because we only need to look at one of those temperature probes, which would be nice. So I went ahead and disconnected from there, and I'm going to hit collect. Erase and store. So notice we only have that temperature 1. Temperature 2 is no longer collecting because I disconnected it. And we're just going to put this wonderful distilled water on it. This is as pure, as close to pure water really as we can get in this school at least, and really anywhere. It's hard to get water without impurity. So we've let it sit for about 15 seconds. So I'm going to go ahead and soak my paper towel with lots of good water, and we're going to let it run for a good solid time. And actually, we can see here, we might have to do some little bit of manipulation here, but we started off, the water was actually warmer than our temperature probe was. So that'll be interesting to see what happens. But I'm going to let this record for the rest of the time, about 200 seconds, and I will bring you back at the very end, and we can record our final set of data for this. Chem Kids, I'm back. Well, it looks like this one somehow accidentally reset the time recording to 180 seconds out of 240 seconds, but we know what, we're still gonna we're still going to take our data. It'll be fine. It'll be fine. So, for water, for our minimum temperature, we see that our minimum temperature was 16.83 degrees. So 16.83 is our minimum temperature. And we look here and we see our maximum temperature was 21.96. So now that we're done with that, we have collected all of our data. All you have to do now is go back and calculate that delta T, and then you have to answer the questions on the next page. So basically, I'm just asking you, which between every trial we did, I'm going to say like which one was the stronger intermolecular force, which one had that stronger force. The way we can kind of think about this is remember that whenever your forces are really, really, really strong, they have very, very high boiling points. They don't want to evaporate if they don't have to. And because of that, the stronger our bond is, the harder it is to evaporate, which means our change in temperature should actually be a little bit smaller. Because a small change in temperature means that there was a resistance to evaporating, and that means we actually have strong bonds. So you want to look and see if the smaller change in temperature is actually going to be your strong bond, and the big change in temperature is actually going to be a weaker bond. And on each of these questions, I want you to kind of theorize as to why it is like that. Why, I know it's a temperature change, and I just sort of explain that. So explain the temperature change, but also explain like why is it bigger? Because like especially in say our first trial, well, they're both just dispersion bonding, but why is one molecule stronger than the other? So sort of talk about that. The last one I want you to talk, or question four, I guess, not the last one. Question four, I do want you to talk about why you think water has such a small delta T value. It is hydrogen bonding, but why is it so much smaller than other hydrogen bonds? And then finally, I just want you to write a little paragraph talking about sources of error. And I know you didn't actually do the lab, but what things could have gone wrong? Why could our results be off? What did I do wrong? Maybe Mr. C did something weird. Maybe he did something wrong. I don't know. But just talk about, what the experiment was, what you looked at in the experiment, and what went wrong. And then you can submit that lab report on Canvas. If you have any questions, just let me know. I'd be more than happy to help you out or to walk you through the whole activity if I need to.